All right, let's jump right in. In this explainer, we're looking at the absolute ultimate intersection of your biological identity and cutting-edge technology. We're talking about the human genome, the literal blueprint of who you are, and how emerging tech is completely rewriting the rules on who gets to own, control, and even profit from your biological code. I want you to think about this question for a second. Who actually owns your DNA? I know, it sounds like something straight out of a futuristic sci-fi movie, but this is a very real conversation happening right now. Imagine your DNA getting hacked. If someone compromises your email, you just change your password, right? But you can't just change your genetic code. Everything that defines you, your ancestry, your health status, potential future diseases, it's all locked in those spirals of your DNA. If that data gets into the wrong hands, the consequences are permanent. Section 1, the genomic privacy dilemma. We are currently facing a massive hurdle that researchers point to as the core problem in modern medicine. It's what we call the genomic data protection Catch-22. See, on one hand, we desperately need massive amounts of genetic data. Combining and analyzing all this inherited healthcare information is literally the only way we're going to cure rare diseases, push precision medicine forward, and truly understand human biology. But on the flip side, sharing that highly sensitive data risks devastating privacy breaches, identity theft, and even genetic discrimination. We need the data to save lives, but releasing the data puts lives at risk. Total Catch-22. And to really wrap your head around the sheer scale of this problem, just look at this number, 100 gigabytes. That is the amount of storage required for a single individual human genome. Now multiply that by the millions of people taking genetic tests. Experts are predicting that by 2025, we'll need 40 exabytes of storage just for genomic data. And currently, almost all of this data is kept in centralized databases, basically massive, vulnerable, ticking time bombs just waiting for cybercriminals to breach them. Section 2, blockchain as your digital vault. So how do we shift away from that anxiety-inducing setup to a highly secure solution? Well, blockchain steps in to solve the crisis. Now, when most people hear blockchain, their minds immediately go to Bitcoin or crypto, right? But here, it acts as this immutable, tamper-proof vault that permanently locks down your genetic information. The benefits for genomics are just incredible. It gives us robust data security through hashing algorithms, speeds up efficiency by cutting out error-prone third parties, drops costs, and most importantly, it guarantees data ownership. You get to decide exactly who accesses your DNA and for what purpose. The crucial takeaway here is the stark contrast between the old way and the new way. Centralized databases are incredibly vulnerable to hacks, heavily siloed off in different corporate institutions, and completely strip you of your ownership. Conversely, federated blockchain learning offers a framework that is highly secure, fully encrypted, and completely user-owned. Your data isn't just sitting in a massive server waiting to be stolen. It is entirely decentralized. Think of it like this. When your DNA is digitized, smart contracts on the blockchain act like the ultimate bouncer. They verify access to your data using a unique cryptographic hash value without ever actually exposing the underlying DNA sequences. So if a researcher wants to access it, the system checks the permissions on the blockchain. If the smart contract says yes, they're in. If it says no, they're completely blocked. Section 3, encrypted AI and learning. Now, this brings up the million-dollar question. If your DNA is locked in a digital vault and researchers can't see the raw sequence, how do they actually study it to cure diseases? It's all done through an incredibly ingenious black box approach. Technologies like homomorphic encryption allow analysts to compute and study your data while it remains fully encrypted. The researcher can literally do the math on your DNA without ever seeing the actual numbers. Combine this with federated learning, where AI models are trained locally right on your device or in your specific hospital, and you get zero trust computing. The AI learns from your genome, but your raw, sensitive DNA never once leaves its secure environment. And the results of combining these technologies are absolutely staggering. One pilot simulation of this privacy-preserving machine learning framework hit a massive 94% precision rate in predictive performance. That's near perfect accuracy. What you should take away from this is that we literally do not have to sacrifice accuracy for privacy. We can train highly effective AI to predict diseases without ever compromising a single individual's genetic secrets. Section 4, real-world genomic pioneers. Because this isn't just theoretical academic talk, let's look at the actual pioneers putting this technology into practice right now. A fantastic example of this is Genomic.io. They've developed an AI family health vault utilizing something called bio-NFTs. You can think of these as tamper-proof digital certificates of ownership for your DNA.
They allow you to set dynamic, supergranular consent. You can literally give a researcher a self-destructing digital access pass to view a specific genetic insight, and you maintain a full audit trail of exactly who looked at your data and when. It guarantees that you and you alone control your genetic insights.
And they certainly aren't alone. Companies like Shivam and LifeCode.ai are building entire decentralized marketplaces. Shivam focuses on things like age-related diseases and diabetes, giving users total control to authorize transactions. LifeCode.ai built a mobile app that lets you track exactly how your gene data is being used in real time. But pushing this even further is a medtech blockchain project by Cloud Control LLC. They're introducing a completely new framework to treat your DNA as a sovereign asset. Specifically, introducing DNAI, the genomics sovereign token for every human's genetic assets. It's a massive leap forward in unlocking global datasets while maintaining absolute privacy.
So what does this actually look like for you, the individual? Here's exactly how you interact with this new token economy. First, you securely encrypt and upload your genetic data. Second, you grant strict, specific permissions using those smart contracts. Third, the AI analyzes your data locally without ever seeing your raw DNA. And finally, you earn rewards. By utilizing tokens like DNAI, you're actively participating in global health breakthroughs, but you're doing it safely and profitably.
Section 5. Owning your biological code. All of these technological leaps bring us to one ultimate overarching goal: absolute sovereignty over your own biological identity. This roadmap shows the direct journey toward complete empowerment. We start in stage 1 with really difficult sharing mechanisms and severe security risks. But through blockchain enablement, we move through managerial techniques right into stage 3, where token mechanisms serve to incentivize sharing and empower the individual. Finally, we reach stage 4, a global behavioral shift where data self-governance and maximized security become the absolute norm. It's a complete revolution in healthcare data. As we step into an era where medicine is profoundly personalized, your DNA is no longer just a biological blueprint. It is an invaluable asset. I want to leave you with this provocative thought about the future of human evolution and personal sovereignty. When your genetic code becomes the ultimate currency, how will you spend it?